Good morning. Today, my name is Adnan. I am from India. I work for a company called as Redmart. We are into online grocery deliveries based out of Singapore. Today, I would want to talk to you about uh, functional programming in a sense wherein not trying to teach you what functional programming is or how to do it. What I'm trying to do is the whole idea behind this talk and motivation was just over a year ago, we started moving from object-oriented to functional programming, and this is more of a documentation of what we learned and how I learned things around. So, and some of the myths that I had, some of the fears that I had when I started, and like a lot of things, people, when I started off, I was told, yeah, you'd need a lot of third-party libraries to do functional programming, and like Android does not really support it in a way wherein you could do it. So we'll see all of those things, I thought about it, the whole entire journey, how the team went about doing it, and how we managed to do it. We'll also talk about a few things like I will try to build a small habit or a schedule kind of a thing which you can follow on your day-to-day life, in your day-to-day work cycle, so that you don't have to make an extreme shift from object-oriented to functional, but can take it at your own pace and learn it as you go on the while. So let's begin, right? This is, when I started off, the first question I read and first things I had in mind was, why is it so hard? Like, why is functional programming so hard? Like, everybody says it is so all the buzz at the moment, but it is so hard as well to understand and to get it right. Well, what I learned is it isn't really hard. The problem with functional programming is it is just more of a change in the view and the perspective of how we see things, rather than the functional programming paradigm itself. It's just that we have been used to thinking about object-oriented programming for such a long time. Like in our colleges, in our education, in our day-to-day work, we have been so used to object-oriented that your mind seems to think object-oriented is much more easier this way, and functional programming is, whoa, I don't understand this, and like, you kind of get all worried. So that from someone who has been a very hardcore object-oriented programmer to now, it isn't that hard. So it is more of a perception versus reality that is happening, wherein a lot of it is the perceived value, where what you read about it online, you see a couple of examples, and it is like so many random things happening. You have no idea what you are going. And at that point of time, you are like, yeah, this is not my cup of tea, and I should stick with what I have known. Object-oriented is our comfort zone. So yeah, we go back to it. But in reality, when we started doing all of this, it was nice in the sense wherein we realized that it is not as hard as it seems. And it is just that the face value and your brain starts to think about it that it is hard because you're just not used to doing it like that. Wow. So the challenge isn't in learning what functional programming is. The challenge is in unlearning what object-oriented programming was. So think of it this way, right? Like, do not think of it as you are trying to learn a new language or you are trying to learn a new paradigm shift. It is more in the sense that you are trying to not have that bias towards object-oriented programming, which you have today. So going forward, we'll see how that maps out, and I'll give you an example to emphasize my point. But what really helped me was having this in mind, that I do not want to do it because everybody is doing it or it is all cool and everything, but try to understand what functional programming is, what kind of benefits it added. Like, for all you know, that it might not add those benefits are not what you are looking, or you or your company is looking for. So functional programming might not make sense. But it is one thing that if you have in mind that you can stop having that bias towards object-oriented programming, the journey would be much easier than what you would perceive it to be. So let's start off by looking at what does it really mean to be functional. Of course, you'll find a million different answers on the internet, so many articles trying to explain the same thing. I'm not going to reinvent the wheel, but while I'm not saying this is a complete list or the exact list, these are some of the things that actually what I understood how functional works, and in my journey, what it meant to me. So functional programming is very declarative and explicit. What I mean to say by that is it likes things to be non-ambiguous to begin with. Like there should not be any ambiguity in what you write and what you are declaring and all of those things. We will look at examples for each of this, but yeah. It also is usually about immutability, and by nature of immutability, concurrency as an added benefit. So this can be very tricky to get your head around it to begin with. We are so used to modifying states within object-oriented programming that the thought of immutability scares a lot of people away. Like, whoa, how am I going to, if everything is immutable, how am I going to do things? And a lot of times, the biggest bugs, problems we have faced have been due to concurrency. Like, yeah, multi-threading, we all know what that is. So it also is a lot about purity. So when I say purity, the idea behind it is pure functions. We will look at what pure functions are and this. But a lot of the emphasis in functional programming would rely around purity, and we would see why it is so important and how it helps as well. There is also something called as referential transparency. This is basically you would want, think of it this way, right? Like given a set of input, you would always expect the method to give the same output. And you would want it to be transparent. Just by looking at the function, you should be able to tell what the function is doing. So that is what referential transparency means in a very loosely translated term. Basically, if you given the input parameters, you should be able to derive the output without actually running the function by hand. And state isolation is something which we'll talk about as well. So state isolation is majorly regarding the fact that since you do not mutate things everywhere and you'd want to do things, so our second point says immutability, right? Like make all things immutable. But if you think about it in a very natural way, if everything is immutable and there are no side effects, then what does the application really do? Like you can't have an app which does not make a API call, right? Like that would be pointless. So we'll look at how we handle those scenarios as well, like how state plays into picture and how functional programming handles state changes as well. So let's begin with the simpler things, right? Declarative versus imperative. So we are all used to the imperative style of programming today, wherein we focus on the how, whereas declarative, which is the functional style of programming, is always focusing on the what. So let's do this with an example, right? So imagine you are at a restaurant and you would want to grab dinner. Simple as that, right? So you see an empty table at the end of the room. You and your spouse are going to go to that table and sit down there. So that is imperative. Like you tell that, yeah, your end goal is just to grab dinner at a restaurant. But you tell, okay, I see an empty table at the end of the room. I and my spouse are going to walk over and then sit down there. You could also do the same thing by saying, table for two, please. It achieves the same thing, basically. You just focus on the what, because you are saying all you care about is at the end of the day that you get dinner is what you care about. Both of those approaches achieve the same thing, but it is just the way you declare. So yeah, we are all programmers. Let's do this. So imperative style, right? Let's take an array, a variable sum. You have a mutable list, and then iterate over the original array, add each element of the array to the sum. If it is an odd number, add that in the list, and that's pretty much what it is doing. Creating a sum and creating a list of odd variables. The same thing with a declarative approach would look something similar to this, wherein you have the same array. Now you take the array and say dot reduce, giving it, okay, this is how I want the logic to be for reducing this equation. and then you say array.filter and say, okay, based on this condition, I want the stuff to be filtered. The, the two pieces of code do the exact same thing. This is functional, that is imperative, and this is declarative for you. The only difference is, in this approach, you do not care what data structure is being used, how it is being added, how it is being removed, is it being replaced. All you care about is, given a list, I want all the odd numbers out of it. So you do arrays.filter. You do not really care about what filter is doing at this point of time here. So I also said that functional means being explicit about everything in nature. You do not want to leave anything to being ambiguous or something like that. So by nature of that, what happens is every function should have a well-defined return type. That is because you want it to be very clear, like, OK, this is the function, these are the parameters, these are the return types. So you declare everything. Yeah, this is what it will return, this is what it will take in. So anybody reading that function knows right away just by looking at it, OK, this is what it's taking in and this is what it's returning. One thing that we are very used to as object-oriented programmers is return void, or unit for that matter, because we are used to doing state changes and mutations right there in the the caller end, that you don't need a value in back. But that kind of does not work, because think about it this way, right? When you are trying to be non-ambiguous, what you end up doing is you want to be very explicit in what is happening. If you now say, OK, this returns a void, then it is very ambiguous in the sense, OK, what happens to with it? What happened in that function? So you don't really know what was going on when you call that function, because it is returning a void to you. You don't know what the function did. So you are now in that mess. OK, like maybe that function could have done an API call, could have written database files, and now you are with a state which you do not have access to, and it would be very tricky to be in such a position. So we would try to avoid unit or void as the return type. I already know what you're thinking is there are cases where there is just no return value for me. Like, there are use cases like that. Right? You don't care about what the return type is. In such cases, you should always at least try to return a result or a failure kind of a thing, so that, let's say you just inserted data in a local database table, and you don't really care if it was inserted or not. But ideally, in the functional world, you would then return, OK, was the write successful or did it fail? So that is, like, I would not do it explicitly. It is the worst thing if you can't have a return type at all. Then at least try to have a sealed class with an error or a success kind of thing, and then return whether it failed or went ahead and did successfully. So by explicit, what I mean to say is you have a function, multiply by 5, it takes in an integer, returns an integer. Just looking at that function there, you already know that I have to give it an integer. It will give me back an integer. It is very clear. There is no doubt. But let's try to do something like this, right? This is much more what Android looks like. So you say, OK, go ahead, call this, take in my interface listener. Whenever you are done, call that listener back. While this is nice, but now we do not have a return type, and we have no idea. The listener can be called from multiple places, multiple times. You have no way of verifying that this call was the actual one who called it back. And you are in a very messy state. So yeah, this is not so explicit. You would want to avoid things like this. We will also, as we progress further, we will look at what we can do about this specifically as well. So coming to immutability, so having variables as mutable could lead to a lot of problems in managing your state of the entire application, and obviously multi-threading issues would occur because everything is mutable and things can change over time without you knowing, OK, this has changed, without having to know. So immutability helps in that sense, wherein since if you have declared a variable x as an integer with the value 2, you can be 100% certain, irrespective of your application lifecycle, that that value will always be 2. So you have a lot more confidence on what you have been writing and what you are. So let's say you have a function which says, OK, calculate this value and returns it back. And those are immutable variables. So you know for sure that you will never have a condition wherein, OK, you expected 2, but something else came out. By the nature, if everything is immutable, then you don't really care about concurrency anymore, because there is nothing that can be shared and mutated. So what would happen is, even if 3 threads call the same function, everybody gets a copy of their own. So you don't really mutate the same state. So it's not like you're running into deadlocks or multi-threading issues either. So immutability and concurrency also will help that way. So when I first heard of immutability, this is pretty much how I felt. Like, we are so used to it from an object-oriented world. Like, it is so easy, right? Like, you write a function, you get a value, you set that value to the object, and then just return that object right there. So you are like, yeah, this is so normal. But then it is very hard to wrap around your head around this idea of having everything immutable and creating copies. And while you are OK with creating copies, one other thing that comes to your mind immediately is, whoa, I'm going to be creating a ton of new variables and memory allocations, and like JVM, garbage collector, is not going to like that. So it can get hard to get used to this fact, but we'll also look at how we can think of something for this as well. So coming to purity, what I mean by purity is the concept of having a pure function in a functional declarative or functional programming world. It produces the same output for the same input. So a function should be pure in the sense, if you give me the same set of inputs and call it 100 different times from 100 different places, the output should remain the same. It should not depend on the context or state of anything else apart from the ones in the only dependency that the entire function should have is on the input parameters being passed, and it should not do anything else. It should, you should never have a case wherein, okay, if I call this from this activity, yeah, this will return this, but if I call that from the same activity with the same set of input from a different activity, then yeah, this would give a different output. That is not there. So you're probably wondering, why do you care about this so much, right? So this helps in the sense it is easier to reason about your code. It is easier to debug it because you are 100% sure that given the same input, the output will always remain the same. And it is much easier to do unit tests on these because they are all similar functions, small unit functions which do one thing and one thing only. They rely only on input parameters and nothing else. Do not have any side effects. So we will, this is interesting, specifically the side effects bit, right? What do I mean by side effects when I say that pure functions would not have any side effects? Is this. So side effect is basically, think of it as anything that you are modifying outside the scope of the current this. So the variables you receive as input parameters are OK to be modified because you receive them as input. But anything apart from that is external context, which your other parts of the application would not know, and changing that would break everything altogether. So a few examples would be like, if you are writing a file to the writing to a file or a database, making a network request, or even modifying the variable. Let's say you have a global variable and you modify it in this function, then that is no longer a pure function because your function now has side effects. So let's look at an example, right? So we have a global variable called z. Then you have a function which takes in x and y, 2 integers, returns an integer. We are being very explicit about it. And then you say return x plus y. This is a pure function because it only relies on the input parameters and returns what it is promising to return. And it does not do anything with the global variable z. So this also is a pure function. It takes in no parameters, returns an integer. But this is kind of useless because Since you can't modify a global variable within a pure function, if you do not have any input parameters, you would always be returning a a constant number or something like that, which I don't think is practical enough. So you could also do something like this, wherein, yeah, you get in two parameters. You take those two parameters, add them up, but do not return them at all. That is also a pretty useless function because there is no point in calling this function because you can't alter the state here. So with that, let's talk about referential transparency. So the idea behind referential transparency is, now that we spoke about what pure functions are and we spoke about they only rely on the input parameters and not the global state. So what now happens is the function is essentially becomes a lookup table. Given x and y, you always know the output of a particular function. So you could effectively do it for all possible values of x and y, and you'd all know the value without even running the function. So referential transparency basically means it should be referentially transparent to the point wherein it is a lookup table, essentially, so that it does not even need. We'll look at why this is important and how this adds value as well. So this is a referentially transparent function because it takes x, y, adds them up, returns it back. Simple as that. And only depends on x and y. So you know for all values of x and y, if you plot the value of z, you exactly know it becomes a mapping one-to-one lookup table. So we spoke about all of those things, right? Why do we want to do pure functions, what pure functions are. Let's look at why we are trying to even do something like a pure function. The biggest thing is unit testing, because since it only relies on input parameters and does not rely on the global state, your unit tests are much simpler because you know exactly what is coming, and you don't have a ton of setup to be done before you start your unit tests. Like say, oh, okay, I need to set up this scope, give it that context, mock these objects. All of that goes away because as long as it is passed in as a dependency inside it, you just need to. Parallelization. So basically, since you now are using immutable data, you use immutability and concurrency comes for free. You could parallelly run the operations on multiple threads and effectively not worry about concurrency and multi-threading issues. The ordering no longer is important. So for an imperative function, it is very important in what order the functions are being called, because you modify the state and you would not want it to be in a state wherein it is tried to access it before it has been returned to. Then that would be a very pretty state. But with these pure functions, the ordering does not make a difference because they do not modify the global state at all in any sense. So you can call them out of order. Let's say you have A, B, C. You could call them A, C, B or B, A, C. It will do the exact same thing. Your application state will not make a difference because the ordering is irrelevant anymore. Since now we only depend on the inputs and we don't modify the global state as well, you get memoization for free because you can now start caching the values of those results. So given x and y, okay, bring back z. And that would be as simple as that. So simple example, you could implement a parallel map which can distribute values over multiple threads, do all the operations which you want to do, and then collect those values back on and give it to you. So you get parallelization for free. Ordering, as I said, do work 1, do work 2, do work 3. I could change the order as much as I want. Nothing would change, and it would still be the exact same result of this function. Since the output does not change for most of the inputs, for all the inputs in this, you could cache and reuse those values effectively so that any time somebody calling this function could return the cached value and does not really need to redo all of this. But by now, you're all thinking that question, if there are no side effects, how do we make sense of all of this? Like, sure, pure functions are nice, pure functions are great, like, on paper they seem perfect, but how do you put it back to an actual application on the real world? So functional programming, this is one of the things that I think was a very big revelation to me when I came across this and understood this particular piece, that it does not eliminate side effects altogether. functional programming would not eliminate side effects, but it would just contain them and isolate them to a place. The idea is if you isolate it at a place or contain them at a place, it is easier to debug, work with, and everything else can be functional as well. So you would want something like 90% of your entire code application to be functional, and 10% is where you would want the mutations to happen, so that you can unit test 90% of it and be overly confident about those 90% without having to worry about the rest 10. So state isolation is basically moving state modifications to the outer boundaries. On Android, it specifically means you want to mutate data, and of course, you fetch data, everything. If you do not show it on the UI, it is pointless. The data is no point of getting that data from the server. So you would want the mutations to only happen on your view layer, because that is where it will reside. All other mutations to data or the type or the logic should not be part of the functional build. It should only restrict itself to the view layer, at least specifically for Android, that is. So function composition is something else that functional programming relies on heavily. Think of functional composition as building a huge house using Lego blocks. So each Lego block is a pure function which you write, and you can compose all of them to eventually build a house with all of those functions. That is how you would want to start architecting your applications. Like everything, start thinking of everything in sense of a function which you can, a pure function which you can write and reuse across and build your application over it. So more like a Lego block, each function is independent and does one thing. But yeah, with when you combine all of them together and compose them together, you would then get the desired result as well. So exception handling is something which we are very used to with Java. Like we throw null pointer exceptions, we handle null pointer exceptions, we do a lot of things with exceptions in general. So while this is fine, but in the functional world that does not make sense, because you would eventually break referential transparency, because you remember, right? We spoke about how we want it to be unambiguous, very crystal clear what the function is doing. But now let's say you have a function which takes in 2 parameters, x, y, returns an integer. And then all of a sudden you do a check, OK, if the number is greater than this or this so-and-so, throw an exception. So now my function definition is lying to me, right? Like it really is not going to return an integer for all possible values of x and y. There are values of x and y now that can throw an exception, and that the function definition does not like reflect the same thing, and that can be very tricky. So in cases of handling exceptions, what you would want to do is model your return types as success failure cases, wherein if you get an exception, return a custom failure object so that you always know, and make that exception a part of the object which you create, and you can always show it on the UI. So you would want to contain your exceptions that way. So now the function definition can say, OK, this guy can return a success of this type or can also return a failure. And we will look at how you put that in a function definition shortly as well. So designing, so let's take a very imaginative scenario. Let's say you have an app, and now you're asked to build a user profile feature. Your app did not have this feature till now, and you are now said, OK, we want to add a user profile as a feature in the app. So think about this for a minute. Like if I come up to you and say, yes, we are now building a user profile, how would you start approaching it is the question. How many of you thought of this? That exactly is the problem. Like, we are so used to, given a problem, we are so used to thinking the first thing that comes to our mind is a class. Like, I need to have a user class, and like I need to have 2 variables, and I need to have getters and setters and all of those things. So it is that habit that needs to change. You need to start thinking, you could have just thought of these functions as well as standalone functions. At the end of the day, this is just ceremony around the functions. The actual logic and what you do is going to rely on these functions itself. But it's just that we have been trained in a way wherein our mind immediately thinks of a class. Like, I have never thought, whenever I have been given a problem, the very first thing I start writing on my IDE is class, and then go there. But with Kotlin, that's changing because you can now have top-level functions. You don't need a class to have the function contained, and you could just import it like a random class how you would. And it would be, that is where you would need to change. Start thinking only in terms of functions. Start thinking that functions are everything for you, in the sense wherein, given a problem, can you think of functions, only functions, and come up with a solution? Do you really need a class is what you need to start asking yourself to move away from that. So yeah, pretty much stop thinking about classes in general and start thinking about functions. I know this is going to take a lot of time and like lot of effort. To be honest, eventually, from when I started this thing, it was not natural to me. But one of the ways I overcame this was every time I used to write the keyword class in my IDE, I would stop a minute and think, can I use a function instead? So trying to actively filter out, have an active this on it that, OK, whenever I write this particular keyword, I need to wait a minute and think of something else. That has been helping a lot in being able to think of functions only and move away from the whole class kind of a functionality, thinking. And so functional programming is not an exact opposite of object-oriented programming. In my opinion, it is just orthogonal to object-oriented, wherein it is not an all-in kind of a game, wherein if you're doing functional programming, you can't do object-oriented programming. In fact, in my opinion, there are tasks which object-oriented programming solves much better than what functional programming solves. And that is where you should start to understand that both of them can coexist together and use what makes more sense in what situation. If it actually feels like you should be doing only functional, then it would be very hard to achieve that because side effects are going to be there, irrespective if you like it or not. Think of that as an imperative shell with functional core in between, wherein all your logic, you would want to write it in a functional way, and only the state modifications as an outer layer on the functional thing. So that can help. So I also promised that we will look at how we can start looking at becoming functional in our day-to-day jobs. So let's look at how, these are some of the tips that I started doing in my day-to-day work life. A lot of people think it is not possible to do functional programming in your day-to-day life if you are using Java or Kotlin or object-oriented in any form. That is not true. I have been trying to do that for quite a while now. And let's see. Every time I write something, I ask myself this question: can this be made generic? Like, as an example, let's say you write a function which says, given a string, parse a phone number out of it and give me the phone number back. Nice function, nice utility function, which is what you would write. When you're writing that, you should ask yourself this: can I make it more generic? And if the answer is yes, then you should try and do that. One way I can think of right away is I could give it a regex, write one function which takes in a regex, and based on that regex, gives back the result. So you could have a generic function for phone numbers, addresses, all of those things. Just pass in the regex. And as we said, you would need to pass in the regex as the parameter because you do not want to be modifying it from a separate state. So thinking right away, wherein every time I'm writing a new utility function, I start to think of a few ideas wherein can this be made more generic? Can I think of a better solution for this in the sense like, OK, why only phone numbers? Like, can this be handle something else? So that can help significantly. Make all things immutable. So what I started as a habit to do was every time I used to declare a variable, I would always start with val. and then let the IDE error out for you whenever you're trying to modify it. That kind of makes you think very hard on your decisions. Like when that IDE gave you an error, that is when you realize, oh, wait a minute, if this is immutable, how would I go about modifying it? And does it make sense to make a copy here, or does it make sense to make it very var instead of val? Because there would be cases where you would want a var as the last resort. I'm not saying you should not use it altogether, but try starting with a val first, and if it does not work out, and if you have to go to var, only then use a var is what I would say. So this was also very, very hard for me to begin with. Like, whenever I started to write a for loop, I deleted that for loop and came up with a solution where how can I implement the exact same logic without using a loop, for loop, or a while loop? So I stopped using loops in general in the entire application because, like, in recursion, loops do not do well because you're mutating values and everything. So basically, in functional, you would use recursion instead, wherein you would call the function over to do loops. So you would want to start thinking about it. Wherever I write a for loop in the IDE, basically, I end up saying, OK, go back. Think of a better solution for this. So as we saw, the imperative versus the declarative function call, which we comparison in the beginning, wherein the imperative iterated over the for loop, added an odds element dot add, but you could have just done it with dot filter on the array itself. So that is nice with Kotlin, giving you immutable data structures, returning immutable data structures back, giving you those functions like filter, map, reduce, flat map. So you would want to get more comfortable with understanding what map does, what flat map does, what filter does, and there are a lot of them, but yeah, with time you would want to start learning them. They actually make a lot of difference. This is not strictly functional, but something which I came up with my own. I stopped using if conditions across my entire block altogether. What I have realized when I started doing this was it forced me to start thinking of better solutions and better ways of structuring what I was trying to do and look at my control flow better. So while this is not functional, you can have if conditions in your functional code. That is not a limitation. Thinking about starting with this and doing this helped me start thinking in a much functional way. And once you kind of know what your thinking is aligned, you might as well start using it again. So a simple 30-day challenge would be to start doing those 3 things. Use just for the next 30 days, take it up as a challenge, mark it on your calendar, use no loops, no var, no if. Do this for 30 days, and I promise you that you'll start thinking in a much functional way, and you would not, trust me, you would not miss the for loops. I guarantee you. So this has been something which has been very effective. Like, I did it for 30 days, and that actually helped a lot in the sense wherein my first instinct today is no longer to look at a for loop when I start iterating. I think of other solutions to begin with. So let's look at a few caveats quickly as to what we have, or how I like to call it, not to shoot yourself in the foot. So it isn't an all or nothing game. As I said, both of them can coexist. Start taking small steps at a time. Don't try to think of it as, oh, it is a huge shift, like I have to move everything to functional, and everybody in the team has to move to functional. That is not the case. One thing at a time. Start looking at avoiding for loops as a general rule. We eventually, in our company, ended up doing that, wherein we set up a GitHub lint rule that if somebody uses for loop in the PR request, it basically warns out saying, oh, you are using a for loop here. So that is something which helped a lot with a lot of people understanding why we are doing that as well. Don't try to be too over-functional. When I say start thinking about functional, I have seen people who have gone ahead and complicated a solution just for the sake of being functional. If it does not feel natural enough as a solution, then you should not be doing it. Like, I would move back to object-oriented for that solution, because object-oriented is much better fit in that case, I suppose. Learn at your own pace. One thing that you don't need to worry about is, oh, this is going to be so huge and there is so much to learn. But try to learn it at your own pace and understand what is happening, and much better that way. And the beauty of it is that, right, you could do it, the 30-day challenge, you could do it in 30 days, or you could do it in 10 days as well. If we are very aggressive at it, yes, you can. But alter the pace according to your this. Have fun, don't stress it out so much, don't be under immense pressure of being functional all the time. It is okay to have imperative as well. We have been, understand that this is going to be a longer journey, like you have learned object-oriented for 10, 12 years now, you can't unlearn it in a single day, so you need to put in the patience and time. Make your life easier. Uh, there are third-party libraries available out there which can make your life much more easier and the entire journey much more easier as well. You don't need to worry about it so much. So you could use those as well if you like to. So Arrow is predominantly the major library out there today, which does a lot of this functional for Kotlin. And I really like Arrow because of the fact that it has been broken down into multiple tiny dependencies. So basically, your core is very different, your data types are different, and all of those things. So look at Arrow. It can help you a lot to make it much easier on you. You don't have to go all in. Don't have to be committed to the entire library. Take it one thing at a time. The first thing I started was I just took the data types library of Arrow and just started using the data types and nothing else. Just do that for a month. Like, let it come naturally to you, understand what is happening, and then go ahead with it. So I'll quickly show a few samples. I promised if we'll talk about how we handle exceptions. So this is, look at that pass functions. The function signature is lying to me because it says it will always return an int, but inside I say, if it does not match, then throw a number format exception. And this is very ambiguous, like, what is going on? You expected an int, you did not expect an exception. If you use the either type from the Arrow KT library, what you get is a data type called as either, and you can say, okay, this function can either return a number format exception or return an integer as well. So now the signature is also not lying. So now you know, oh, okay, this can return an exception. It is telling you what is exactly expected. So yeah, then if either right left, either dot right, this is okay. So at the call side, this is how it would look like. You say parse 2, and now due to the either dot left and either dot right, what you get is when x, you can check, oh, okay, if this is a left, is this a number, throw a number format exception. If this is a right, just go ahead and print the actual number which your logic is. So this is much simpler, much easier. It is, the signature is telling you what you need to do. Either does that for you. Either is just another simple data type. You do not have to use Arrow KT. You could write a sealed class of your own type and pass this, and you could achieve the exact same thing without Arrow KT as well. So there is something called as an option type. Nulls are our favorite values in our programs. We love nulls. So how can we not talk about nulls? So let's say you have a value which can return a possible null. What you say is option of string. So what option of string says is, oh, OK, this is supposed to give a string, but at times can be null as well. So yeah, and we do that, is none. And when you say, you could say when, is sum, is none. If sum, then you get the value. Is none, you say, oh, OK, this is a null here, right? Yeah. I/O is something very similar. Get data. You have something called as I/O. Then it says, so this basically tells, OK, this is an I/O computation. This function says, OK, this is going to make an API call or a database write. And yeah, Arrow KT and Charles is a very great this as well. Thank you.